about recursion. In this video, we're gonna look at some examples of recursion, specifically the Fibonacci sequence. We're gonna look at how the recursion tree looks like when we call the Fibonacci sequence. But first of all, what is recursion? Simply, recursion is a function calling itself. But you may think, when a function calls itself, it may run infinitely. So, it's important to have these two cases in recursion, the base case and the recursive case. So in recursion, the recursive case represents the function calling itself and dividing the problem we have into a smaller problem of the same nature. The answer to the problem we have relies on solving the smaller problem of the same nature. We may see the example when we solve the Fibonacci sequence. It may call the recursive case until the base case arrives. When the base case arrives, it tells the function to terminate and stop, and there are no cases to look at. So when we arrive at the base case, we may return the result to the previous problem we have until solving the main problem. So now, in order to understand recursive calls more, let us look at this example on Fibonacci sequence. First of all, what is Fibonacci sequence? Simply, a Fibonacci sequence is a sequence where the sum of the two previous numbers result in the next number. For example, the summation of 0 and 1 results in 1. 1 and 1, 2, 2, 3, 5, 3, 5, 8, and etc. It's an infinite sequence of numbers. So the problem may ask you, return the nth Fibonacci number. What is the nth Fibonacci number? It's the index of the number. You may visualize the index of the Fibonacci number. So if they told us to return the fifth Fibonacci number, it will be the number 5. If they told us to return the third Fibonacci number, it will be the number 2, and so on. So, how shall we solve this problem recursively? Let's discover. As you can see, the function for Fibonacci sequence is divided into a base case and a recursive case. And it's always the case in recursion problems. There are always a base case and a recursive case. The base case tells us to stop, and the recursive case to solve the smaller problem of the same nature. So here, how it's solving that? The function Fibonacci fib is taking an integer n representing the nth Fibonacci number. It checks. If n equals to 0, it returns 0. If n equals to 1, it returns 1. Meaning, the base case I have a number either 0 or 1. If it's 0, I return 0. And if it's 1, I return 1. However, if it's greater than 1, I call the same function n minus 1 and n minus 2. For example, if it's 2, it's the sum of n minus 1 and n minus 2. 0 plus 1 is 1. Let's say it was 3. Or the nth Fibonacci number is 4, meaning 3. So the summation of 3 relies on the number before it and the number before it also. So 2 and 1 sums to 3. But these two numbers also rely on previous summation. So 2 relies on 1 and 1, and 1 relies 1 and 0. So in order to more understand the recursion of the Fibonacci sequence, let's see the recursive tree of the Fibonacci sequence. In order to draw the recursive tree of the Fibonacci sequence, let's take an example of fib of 5. We will return the fifth Fibonacci number, which will result in 5. So first of all, we call fib of 5. 5 is neither 0 or 1, so it calls this. Answer to fib of 5 relies on the answer of fib of 4 and fib of 3. But now, imagine this is called on a separate code. So it will also run here. It's neither 0 or 1, so we'll also call fib of n minus 1 plus fib of n minus 2. So fib of 4 will do the same process. The same goes here. Now I have reached a base case. I am at fib of 1 and fib of 0, right? So the n has reached 0 and reached 1. So this call will never be executed. Either one of these two will be executed depending on n. So here n is 1, so it will return 1. Here it's 0, so it will return 0. Now, fib of 2 relies on the summation of these two. So 1 plus 0 is 1. Here it's also fib of 1, so it will return 1. Fib of 3 relies on the summation of these two, so this would be 2. Fib of 2 would also be recursive and not a base case. So now I have 2 and 1, so fib of 4 is 3. The same process that happened here will happen on the right side of the tree. So let me simulate it. As you can see, I have solved similar problems in nature in order to solve the bigger problem. So now I have 3 and 2, I sum them, I get 5. So the fifth Fibonacci number will be 5. This was it for the Fibonacci sequence. I hope you enjoyed the video. If you have any questions, put them down below and I'm happy to help. See you in the next video.